Math 1314, Tyler Junior College, Section 1.6, Other Types of Equations. Solving square root equations double. In other words, your equation starts out with not one but two square roots. For example, we're going to solve the square root of 5x plus 1 minus the square root of x plus 1 is equal to 2. Now, how are we going to do that? We have a technique for solving a single square root equation. How can we solve a double square root equation? The premise is still, it's not kind of the same, it's exactly the same. We're going to have to square to get rid of some square roots, but here's the catch. If I square it right now, which is actually not a productive move, it's not wrong if you do it correctly, it's just not super productive. If we square both sides right now, I can't just distribute the square across the subtraction problem and cancel both square roots. There is no such distributive property. How would you square this? Write it out twice and FOIL it. Is it possible? Of course it is. Is it desirable? Not really. But why don't we just try what we did before? Isolate the square root. Still got this on here. Square both sides of the equation, solve the remaining equation, and check for extraneous solutions. But do you see the problem with trying to execute this technique? Well, the first move says, if necessary, isolate the square root. I can do that, but which one do I isolate? There are two square roots. And what happens after I do that? I'm trying to get this ink off my, oh well. Well, let's find out. If we follow the procedure that we already established, we need to isolate a square root. And which one do we want to isolate? Well, let's isolate the first one. Why? Why not? I have to make a choice. By the way, either choice would work. I just happen to choose the first one. Okay, so if we want to isolate the square root, we're going to have to move this one to the other side by adding it to both sides. So if I move it to the other side, it's going to become positive. And as we start getting our answer, we have the square root of 5x plus 1 is equal to 2 plus the square root of x plus 1. Okay, so we've isolated one of the square roots, and in which case our next move would be to square both sides of the equation. I know what's going to happen on the left. The isolated square root will lose its square root. But on the right side, I have to square the quantity 2 plus the square root of x plus 1. We'll deal with that in a moment. On the left, the square and the square root cancel, leaving us 5x plus 1. But how are we going to square the right? Distribute the square? No. You cannot distribute powers across addition or subtraction. I'm going to sound like a broken record by the end of these videos, but you cannot distribute a power across addition or subtraction. So how do we square this binomial? Well, the same way we square all binomials. We write it twice and FOIL it. But that has a square root inside of it. Yeah, so this is still can be viewed as a binomial times a binomial. 2 plus that times 2 plus that. Which means we can FOIL it. You can FOIL that. We can try. Let's see what happens. We start with 5x plus 1 on the left. That's pretty harmless. On the right, 2 times 2 is 4. That was easy. Plus the outside, 2 times the square root of x plus 1 is 2 times the square root of x plus 1. Okay, you can buy that. The inside, 2 times the square root of x plus 1, so the exact same thing. By the way, if you haven't figured it out yet, when you multiply a binomial times itself, the outside and the inside are always equal, so technically you only have to do it once and double it. But let's just stick with FOILing. So we just did the inside, now we have to do the last. The last is the square root of x plus 1 times itself. But that's the very definition of squaring something. So the last part is the square root of x plus 1 squared. That's convenient. That cancels the square root there. So we have 5x plus 1 equals 4 plus, let's go ahead and combine these into 4 square root of x plus 1. And then over here, the square cancels the square root and we're left with x plus 1. We get some like terms that we'll combine in a minute, but let's stop and figure out what's going to happen next in this flow. We just did move 2. We just squared both sides of the equation. The third step is to solve the remaining equation. What type of equation remains? Answer, a square root equation. So this third step, solve the remaining equation, means that I'm going to have to start over on that. But that's okay. So we're going to start over on this. We need to start by isolating the square root. Let's start by combining this 4 and this 1. There's a multitude of things you could do next, but I don't like uncombined like terms. So if we combine the 4 and the 1, we get a 5. And just for clarity, let's move the stray x here. I don't have to, but I'm going to. And then plus 4 square root of x plus 1. I want to isolate this guy, which means I need to get rid of everything on the outside of it. Now, resist the temptation to combine the 5 and the 4. They're not like terms. This 4 is part of this massive term. The 5 is not part of the square root of x plus 1 term. So let's start by getting rid of everything that's added and subtracted. And I'm going to physically do these subtractions instead of just saying, move it over. That would get rid of these. You know why I'm not doing minus 4? Because the 4 is not attached to this by addition. The 4 is attached to the square root by multiplication. To get rid of it, I'll have to divide in a moment. 5x minus x is 4x. Positive 1 and negative 5 is negative 4. These are gone, and I'm left with 4 times the square root of x plus 1. But the square root is still not isolated. It has a 4 multiplied in front of it. And how do you get rid of something that's multiplied? Divide. Normally I would be a little concerned about dividing a polynomial by 4. But if you'll notice on the right side, if I split this, the left side, if I split this into 2 fractions, they would both reduce. 4x divided by 4 is just x, minus 4 divided by 4 is 1. Here the 4's cancel and we get the square root of x plus 1. Yeah, we're not out of the woods yet, hardly. But at least we're to a point where we can see the light at the end of the tunnel. Remember, I just started this process again. I just isolated the second square root. Now it's time to square both sides. Running out of room here, so we'll say goodbye to this. And we will resume solving up here. So we have x minus 1 equals the square root of x plus 1. We've isolated the other square root. Now it's time to square both sides. So x minus 1 squared equals the square root of x plus 1 squared. The square cancels the square root, so the right side is just x plus 1. But on the right side, we do set up another FOIL problem, x minus 1 times itself. So if we FOIL that, we'll get x squared minus 2x plus 1 is equal to x plus 1. And now we finish solving this, and it's a quadratic equation. So let's get it equal to 0. Since the x squared is already positive, let's leave everything on the left and eliminate everything on the right. So subtract x from both sides and subtract 1 from both sides. That'll empty out the right and leave a 0. On the left, we have x squared minus 3x, and that's it because the 1's cancel. I could use the quadratic formula on this. C would equal 0, but I can solve this by factoring really easy. These two terms have x in common. So factor out an x, and that leaves an x minus 3. Set each factor equal to 0. And solve. So we seem to have two solutions. X is 0 and x is 3. seem to have two solutions. Do you remember what the last step is in solving a square root equation? You have to check your solutions for extraneous solutions. So despite everything that's happened, the first isolation in squaring, the first congested foil problem, the second isolation in squaring, the quadratic equation, we're still not out of the woods. We have to check each solution for extraneous solutions. So I'm going to remove all this. And I'm not worried about removing it because if you were going to write it down, you could always go back and pause the video. So let's check these solutions. And by the way, you do have to always check your solutions. I have seen square root equations where one solution is good and one is extraneous. I've seen square root equations where both of them are good, and I've seen square root equations where both are extraneous and the equation had no solution. So you can't just assume one will work and the other will not. Let's check x equals 0. And let's do this a little efficiently. We want to see if it's going to equal 2. So if we substitute 0 everywhere there's an x, we get 5 times 0 is 0 plus 1 is 1. And over here we get 0 plus 1 is 1. Well, the square root of 1 is 1. The last time I checked, 1 minus 1 is not equal to 2. So it doesn't take too long to dismiss the 0 as an extraneous solution. But what about checking x equals 3? Again, we're checking to see if it's equal to 2. If we put 3 in the first square root, 5 times 3 is 15. 15 plus 1 is 16. And if we put 3 in the second square root, 3 plus 1 is 4. The square root of 16 is 4. The square root of 4 is 2. 4 minus 2 is 2. The 3 is our only solution. So as you can see, a double square root equation gets a little bit funky because you have to isolate the square twice, and in the middle is an inconvenient FOIL problem.